Okay, so in this week what we're going to be taking a look at is we're going to be trying to extend this idea that we worked on last week in terms of normal distributions. It says, what are the statistical measurements that can be used, that we can use sampling and sampling distributions to target the values of a population? So what I want to talk about is when you see a stat like something like, what is the average height of a male? How do they get a number like that? Well, what we're going to do is we're going to use a concept called sampling distributions to try to figure out what that population value is, because it's really hard to get certain population data. The statistics that the measurements that we can use sampling distributions for are the mean, the variance, and proportions. So when you think about means, this is average, right? Variance, remember, this is the measure of the spread. And proportions, remember, are percentages, like what percent of people are left-handed. So it says, in your own words based on a video, show how sampling distributions are used to find the data value for a population. So let's think about this. Let's say I wanted to find the percent of people who are left-handed. So I know that there is some p-value for the population. I use p for proportion. There is some population value that is the percent of people who are left-handed, but it's really hard to find because I would need to ask everybody in the entire world if they're left-handed or not. So what we start to do is we start to gather samples. A sample proportion we represent with a value p hat, just kind of like x bar for the average of a sample. P hat is the proportion for a sample. So let's say I take a percent and I find that, let's say I find that 8% of people in my sample are left-handed. Then I take another sample and I find that 12% of people are left-handed. And then I find a sample and I get that 11%. And then I get below again. And then I get a sample where there's a lot of people in this sample that's left-handed. But what I'm starting to do is I am sampling over and over and over again. So what we do is we just sample and we sample and we sample some more. So I'm just going to keep sampling, and I might get a repeat value. So just like we would do with a histogram, I would just stack it on top. And again, I might get one that doesn't have anybody that's left-handed. I might get a ton of people that's left-handed. But most of these values, as I start to build up, you can see that what's starting to form is, as you continue to sample, you will see that these samples start to form a normal distribution. And here's what the deal is. If you sample enough times, if I keep sampling enough times, you're going to build a normal distribution. And then if you find the mean of all of those samples, sorry, that was not a great. If I find the average of all of those samples, so I just average all of those means up, you will get a value that targets the true proportion of people who have are left-handed. So again, it's impossible to get a population number. So what we do is we repeat the sample over and over and over again, build this distribution, and then find the average of that distribution, and that targets the population parameter. So this is for you to answer. So put in what you would like to put right here based off of what I said over here. So it says, when calculating probabilities of samples having a particular range of values, what do we need to change about the problem? When you are working with sampling distributions and you're working with probabilities, you need to change your standard deviation, because the standard deviation is going to be different for a sample of people as opposed to picking out a single person. So how do we calculate the standard deviation of a sampling means? What you do is you take your old standard deviation for the data set and you divide it by the square root of the number of samples you have. And this is the standard deviation you're going to use when we're working with sampling means. We'll get a little bit more into this in the next example. So to do a quick one for you, it says the average systolic blood pressure for females is 106.3 with a standard deviation of 8.9. So we know that in our sample, we've got a mean of 106.3, and we've got a standard deviation of 8.9. It says, what is the probability that a randomly selected female will have a blood pressure greater than 112? So what we're looking at here is we are looking at a normal distribution with a mean of 106.3, and we are seeing what is the probability that their blood pressure is greater than 112. So 112 would be here, greater than is this way. So we are finding the probability that X is greater than 112. And to do that, remember we use the Microsoft Excel spreadsheet. And this time we're going to pick, when we take a look, we're going to see this is shaded to the right, correct? So we're going to pick the tab for left and right, and our mean is 106.3. Our standard deviation is 8.9. And we are going to find the probability that it's greater than 120, right? So we're going to select, this is the values that are the probability of selecting a single person whose blood pressure is greater than 120, which is 0.0619. We'll round that. Or about 6.2%. Okay, so this just says, what is the probability that if you pick 22 females, that the average of their blood pressures, or the mean of their blood pressures, is between 101 and 107. So this time I'm not finding the probability of a single person. You can see in this one it was a randomly selected person. Now what I'm going to do is I'm going to take 22 people, I'm going to average up all of their blood pressures, and I want to know what the probability is that it's between 101 and 107. We're going to go a lot more in depth into this in class next week, but this distribution is actually, if I were to look at it, it's going to be like, compared to the other one, it's going to look like this. It's going to be much more steep. It's still a normal distribution. We're still going to have an average of 106.3. But when I go to find the area between 101 and 107, I think we're going to have a lot more area in there. So this time you can see that we're shading in between. So this is 107 over here. But since I have 22 females, this is what I talked about up here, which is we need to change that standard deviation since we are taking the mean of a bunch of people's blood pressures. So it is going to be our old standard deviation, which is 8.9, divided by the square root of, I have 22 people in my sample. So I'm going to use my calculator. Sorry, got to give it a second to get booted up here. So this is going to be the standard deviation that we're going to change. The mean is going to stay the same, but our standard deviation is going to be 8.9 divided by the square root of 22. And that gives us 1.90. We'll round this 2 decimal places. Or actually, let's take it out for 1.8975. So this would be 1.8975. So now this is going to be my standard deviation. My mean is still 106.3. And this time you can see we're going to use in between, right? Okay, so we're going to go to our Excel spreadsheet. We're going to be working on this one down here. So this is between 101 and 107 with a mean of 106.3, and then we're going to change that standard deviation to 1.8975, and we get the probability is 0.6413. So the probability that somebody's blood pressure is between 101 and 107 is equal to, what did I say, 0.6413. So pretty similar, but again, when we're taking a sample, we need to change that standard deviation. The last thing is, it says, we're going to use the normal distribution to approximate some harder to find binomial probabilities. What are the requirements for us to use the normal to approximate the binomial? We're going to go into this in more depth, but the main thing is n times p must be greater than or equal to 5, and n times q must also be greater than or equal to 5. Remember, n is the number of trials, right? P is the probability of success, and q is the probability of failure. Now, these are going to be some of the trickier things that we're going to do in Chapter 6, so make sure you focus in on this, but this is just going to be a baby step. We can use the normal to approximate the binomial if these two conditions are met.